Good evening, students. Very warm welcome on the new year 2021. And my dear students, 2021 has begun, and our resolution is that we will not waste even a moment of life in the year 2021. The difference between successful people and those who are not successful is how much hard work you put, students. Hard work, focus, and determination are the keys to the success. Therefore, students, I would say that begin your year 2021 with hard work, concentration, focus, and determination to get full marks in the examinations. If you take a decision, students, you can act on it. If you think, believe, and act, you can do it, students. You can do it. Yes or no?
Yes, sir.
Okay. So, my best wishes to you and your parents, your family on this new year. And we take a firm decision that we as a coach are determined to teach you the best, and you as a student are determined to learn the best. And I will not waste a moment of life. You will also not waste a moment of life. Okay, students, is it
Yes,
okay?
sir.
Done?
Yes, sir.
Okay, both of us work together, students. It is not you, me also, everything applies. The important session, very important session, students, in the chemistry, that is how to write the full electron configuration of different atoms. Student. Very important topic, very important topic. You know that this is going to the most important topic, student. How to write the full electronic configuration of elements student. How do we write the electron configuration? Mean distribution of electrons in an atom. What I told you, you know that, student. First thing, you know that different elements different elements, student, or different have different atoms, have different atoms, student, you are saying. And there are different number of electrons, keep on with me, student. Different number of electrons. Be with me, students, all the time. Keep on interacting with me. These are live sessions. Have energy, students. Energy level should be high. So they have different number of electrons, 1 2 3, as per the atomic number. With the atomic number of the elements is giving you number of protons and number of electrons. Yes or no? Fast.
Yes,
So
sir.
you have atomic number 1 2 3 and so on in the periodic table, student. Atomic number 50 up to 118 is what you see in the periodic table. These are the different electrons. So the question is, where are these electrons inside the atom, student? What is the address of the electrons in the atom? So we have to distribute different electrons for different elements inside the atom, students. So we want to know which shell they are present. And for this, student, we already told you what we told you. There are 4 set of quantum numbers, students. 4 set of quantum numbers. Did I tell you about that or not? Tell me how many
No, sir,
quantum
you
numbers
didn't.
I told you. 4 set of quantum numbers. Okay?
Yes, sir.
They will specify, student, they specify the state of the electron in the atom. State of the electron in an atom. Are you with me, students?
Yes, sir.
Where is the electron? What is the energy of the electron? What is the distance of the electron from the nucleus? What type of orbitals are there in each shell, students? We told you. So there will be 4 set of quantum numbers which were coming directly from the solution of the Schrodinger's wave equation. The mathematical equations have been solved, and on that basis they gave us 4 quantum numbers. Our purpose is that we will use these quantum numbers for writing the electron distribution, because they different quantum number for a small thing. The reason you see, first one I told you is a principal quantum number, student. Principal quantum number was represented by n, and what values it can have, student? 1 2 3 4, 5, and so on, student? Yes or no? Fast.
Yes, sir.
This is the first shell, L, M, N, O.
And
So,
O.
what the principal quantum number gives you, student? It tells you the energy of the electron in the atom, as well as the what it tells you, the size of the size of the orbital. What you said is the distance of the electron from the nucleus.
Yes, sir.
Distance of electron from the nucleus.
Yes, sir.
Okay, very good. Thank you for interacting. So you are saying that this is a nucleus, student, and what you said, there are shells in this, students. What shells you are talking about? These are the shells, students. K, L, M, and so on, student. As you go n equal to 1, 2, 3, 4, 5. So you say the energy is increasing. The energy is increasing, student, as you are going from first shell to this. The second one, you are saying this is our K shell, this is our L, uh, M, N, and so on. The energy is increasing. These are the shells in which there are electron, students. But then these, you know that for everything, this is just an approximation, as experimental information is there, students. You know there are sub levels. There are sub levels. Sub
Yes,
levels.
sir.
So the sub levels were represented by a second quantum number, student. This is my first quantum number, which I am saying. The second quantum number is called the azimuthal quantum number, students. What was that azimuthal quantum number? It was represented by L, student. It gives there are shapes of the orbitals, shapes of the orbital, students, that there are subshells, and there are in the subshell, there are orbital, students. What do you mean by that? It says, it is said that if, for example, in the K shell, there can be only one. If you have a K shell, student, the first N is equal to 1. You have in this one subshell. What you have? One subshell. And which is that, then for this there is a azimuthal quantum number which gives the shapes of the different orbitals. There are sub levels, what I am talking, subshells. So the subshells are, students, in the shells there are subshells which are given by the azimuthal quantum number, and we say that, which are, we told you, S, P, D, F, and so on. These are the subshells, students. ठीक है. And what are the values of L? L can have value, student, 0. When there is one S, we say L is 1, 0, 1, 2, 3, up to n minus 1. So mathematically we can say that if n value is 1, if n value is 1, student, then what will be the possible value of L? 0. That is what we call as, it is S subshell. ठीक है. And if n is equal to 2, then what are the possible values of L? 0 and 1, because the last value is n minus 1. So this is my S and this is my P. So these are the orbital, students, which are present in the shells. So this is given by the azimuthal quantum number, student. You have noted down everything. Okay. The third important point is, you already know, students, what are the shapes of these orbitals. The shapes of the orbital, students, the shapes of the orbital, students, is known to you.
Um,
What are
yes,
the
sir.
shapes? We have shown you the shapes of different orbitals. Is different. What are these orbitals? The probability of finding the electrons around the nucleus, students. We have shown you the s orbital is spherically symmetric. And what are the shapes of the s orbital? We have told you is having a spherically symmetric shape. So you can see in the books they have given the distribution of electron density around the nucleus, and then you know that then p orbital, there are three p orbital, students. If I take x, y, and z axis, student, if I say x, y, and z axis, then what you have? Dumbbell shaped. Dumbbell
Yes, sir.
shaped. You have, supposing this is my 2px, so you will have 2p z, 2py, and you will have 2pz. ठीक है. So there will be p orbital student, which are given, which we say that the shapes of the orbitals, to the L quantum number which we are giving students, which give the subshells, it is also related with the energy of the electron, because the energy of the electron not only depends on the principal quantum number, it also depends on the L value students. The energies of the electron, the energy of electron in the atom depends on one n value, principal quantum number, and also on the L values. Also on the L values, because Aufbau principle will use this idea, which we will tell you. And you know the shapes of the d orbital. There are 5 d orbital students. The shapes of the d orbitals, you think they are double dumbbell shape students. So they are represented, if this is my x y, one of the d orbital I am showing students, there are more than this 5 dxy dyz. You have dxy, dxz, dyz, dx square minus y square, dz square. There are 5 d orbitals. How many? 5. So they have different shapes, students. So for different values of n, we can find the values of this. If n is 2 students, then L can be 0 and 1, which is s orbital and only p orbital. So in the, you can say that in the, if n is equal to 1, the only possibility value is 0, which is s. So in the K shell student, how many subshells are there? Only one subshell. Only one subshell. That is your S. Okay? That is your
Yes,
S
sir.
in the K. So n is equal to 1. So I am representing it 1s. But when I say n equal to 2, how many are possible? For n equal to 2 students, you will have L equal to 0 and 1. So when L is 0, what will be this? This will be S, and then there will be P also. This I'm saying 2S and 2P. So there are L equal to n equal to 2, 0 means S, and L equal to 1 is P. That means this is 2S and 2P. So we have already told you now L 0, 1, 2, 3. What designation names have been assigned to
Can you
them?
explain
S.
that to me again, sir?
When L value is 0, S orbital. When L is 1, P. L equal to 2 is called D. L equal to 3 is called F, and so on.
Okay.
So the values of L will be decided by the value of N. N is the shell in which there are subshells, students. In the subshells there are orbitals, but different orbitals can be there in the same shell. In the first shell, only one orbital is there, 1s. In n equal to 2, you will have 2s and 2p. If n is 3 student, and 3 is still higher in energy than this. When I say n equal to 3 students, what it means, students? Then n is equal to 3 will mean, what I'm saying, n is 3 means L can have 0, 1 and 2. The final value is we have given mathematically, after studying the experimental result, student, what we are saying, the final value of L can be how much? 0 to n minus 1. L takes values. What are the possible values of L? We are saying 0, 1, 2. The last value is n minus 1. Last value is n minus 1, students. So n minus 1 is the last value for L. So if it is 3, then 3 minus 1 will be 2. So it can have 0, 1, 2 value. That means there will be S subshell P and D. So in n equal to 3 student, how many sub levels will be there? 1, 2 and 3. In n equal to 3, there will be how many? There will be S, P and D. S, P and D. Similarly, n equal to 4, there will be 4 sub levels. How many 4 sub levels will be? These will be 3S, 3P and 3D sub levels. And when n is 4 student, there will be 4S, 4P, 4D sub levels, which will be present in those shells. Clear? This is coming from the azimuthal quantum number. Now I'm coming to another quantum number which is required, student, because student, you can see that you have got the shapes of the orbitals. Okay? I have not drawn the shape of f orbital. It is more complex than d, because there are 7 f orbitals. How many? 7. They are 3-dimensional. So when mathematically they are calculated, student, from the boundary surface plots, and therefore it is not possible to show on this. The shapes of the orbital, student, you have seen. Now the orientation of the orbitals. Orientation of the orbitals. You can see the shapes of s orbital, p, d in the book, student, any book. There are 5 d orbitals which we have shown you. Okay? Orientation of the orbitals I am talking. Now the orientation of orbital is that there in the first, in the k shell, student, this is my k. N equal to 1, L equal to 0. You have only one s, only one. Okay? There is only one subshell here, only one orbital. And one s is spherically symmetric. One s is spherically symmetric. But students, when I come to L subshell, L shell, n equal to how much? 2. N is 2 and L values are 0 and 1. The S is spherically symmetric. S is spherically symmetric, no problem. You have 2S. But when I say 2p, student, the orientation of the 2p orbital, how many 2p orbitals are there, student? How many 2p orbitals are there? These values are given by another quantum number which we call as a magnetic quantum number, student. Magnetic quantum number, which is represented by ml. So it says that there will be total of 2l plus 1 possible values, 2l plus 1 possible values for the orbitals when l is 0. Then 2l plus 1 is how much? Tell me. 2 into 0 plus 1. Only 1. So that is our s orbital. There is only one s orbital. But when L equal to 1, students, how many orientations will be possible? 2 into 1 plus 1. There will be 2 into 1 plus 1 is how much? 3. So there are 3 p orbitals, students, which we have just shown you. How many p orbitals are there? 3. One you are saying 2px, 2py, 2pz. How many? 3 p orbitals are there, and their values can be represented like, student, plus L to 0 to minus L mathematically. That means if L is equal to 1, it can have plus 1, 0 and minus value. Mathematically, we are just saying this is a way to represent them. So one is 2px, other is 2py, and other is 3pz. So students, in the L shell, students, then what is the story? You have one 2s orbital, and how many p orbitals you have? 2s, 2p, 2px, 2py, and 2pz. Okay? There are 3 p orbitals. How many are there? 3 p orbitals. Can you see that? One will be x, y, and we have seen their orientation located px. And if L is equal to 2 students, then how many total values are possible for the magnetic quantum number? This is my ml value, students. This is my total ml value. What is the total ml value given? 2l plus 1 mathematically means what? 2 into 2 plus 1. How many? Fast, 30 seconds. How many will be there? 2 plus 2 plus 2 into 2 plus 1 is how much, students? What is this value? When L is 2,
It
fast
is
answer. 2 into 2 plus 1 will be how many values? How many orbitals are coming?
4.
2 into 2, 4 plus
Sorry,
1,
5. 5.
5. So student, L equal to 2 means what? I told you L equal to 0, L equal to 1, L equal to 2, L equal to 3. This is our S orbital, this is our P, this is our D, student, and this is represented by F and so on. Even these are enough for our elements of 118. We can write the electron configuration of all the electrons which we have for all the atoms. We don't need, if I say L equal to 4, student, then this will be represented by G and so on. Okay? I can go. So here for this is my D orbital. How many D are coming? 5. How many D are coming then? Tell me. 5.
Yes, sir.
So which we have already told you that there are 5 d orbitals, student. The shapes, if you want to see, we have said that you can read any book. They are double shaped, so they are oriented towards xy z axis, in between also xy z axis, students. 5d orbitals. So students, in other words, if I will go higher than this, what will happen? Then we can represent these for n equal to 3. When n will be equal to 3, student, that is which shell? KLM shell. This is my KLM. In the M shell, when n is 3, then L can have value 0, 1, and 2. So you will have S, P, and D. S will be how many? 1, P will be how many? 3, and D will be 5. So if I go further, students, for example, if I have to show like this, students, what I'm trying to tell you, we have shown some energy picture here just to explain to you, students. I hope you are getting my point, students. So you are saying this is my K shell. If I will come to the next student, which will be that n equal to 3, M. So in the M you will have how many orbitals will be there? You have 3s, n equal to 3 means 3s, student. How many P will be there? 3px, 3py, 3pz. How many? 1, 2, 3. And then there are 3, 5d. How many d orbitals are there, students? There will be 5d. Okay? So you will have 1, 2, 3, 4, and 5. These are my 5d. Which are those? dxy. This is my 3d. 3dxy, 3dyz, 3dxz. This is called 3dx square, y square, and this is 3dz square. How many they are? So total how many orbitals now you can see here? 1 plus 3, 4, 4 plus 5, 9. How many are here? Total number of orbitals, number of subshells you are seeing, student, number of subshells or number of orbitals, how many? Here only 1, here how many? 4. How many here? 3, 1 plus 3, 4, 4, 4 plus 5, 9, like this. And if I go, student, to this is n equal to 3. If you will go further, student, that will be my n equal to 4. Which shell will be that? K, L, M, N shell. In that you will have, student, 4s, 4p, 4d, and 4f also. Which subshells you will have here? There will be 4s. S is always 1, 4p, 4d, and 4f. How many of this will be there? 1. How many of this will be? 3. How many of 4d will be there? 5. And 4f will be 7. So this is how there are in the different shell, students. You have subshells, and these are what we are saying. There are orbital, students, in which the electrons live. So shells, subshells, orbitals. The number of orbitals is different. Different is not the same. For it will depend how many electrons an atom has. Okay? So we have seen the third, and there is another quantum number, student, which was required in order to explain the building up of the electrons. What is that fourth quantum number? What is the fourth quantum number? Can you tell me? That A, B, C. You have told A, B, C. Now the fourth quantum number is called the spin quantum number, student. What was the need of that? You already know that when experimentally spectral lines were observed, students, for multi-electron system, there were doublets. So spin quantum number, student, is the fourth one, which we say ms. It means electron can spin, students. Electron can have positive spin, which we say ms value given as plus half, or electron, this is a clockwise spin of the electron, or electron can spin in the anti-clockwise direction, students. So this I am saying it has a spin minus half. So electron can spin clockwise or electron can spin anti-clockwise direction, students. So this is another quantum number. This is the last one which we are giving as the spin quantum. Okay? The electron can spin. You see, electron is spinning around its axis. Electron is orbiting around the nucleus, also spinning around its axis. What are the possible ways? Clockwise or anti-clockwise. So we may represent it like this, clockwise, then we may represent it like this. This is the spin of the electron. Okay? So there are 4 set of quantum numbers which are going to help us, students, in building up the distribution of electrons in an atom. What we are trying to go? We are trying to build, what we are building? The electron configuration. Okay? Up to now, you got the idea what I am trying to do, students? Tell me. Is it clear up to now? Any doubt?
No, sir.
Are you with me? Yes or no? Fast.
Yes, sir.
You will get the video recording also. If you have doubt, you can see. Another interesting thing which I should tell you before I go further, student, there is something called degenerate orbitals. degenerate orbitals, students. What are degenerate orbitals, student? Which have the same energy. Same energy. Why did I need that? Because in the filling of the electron, this will be very important, student. Which will be the degenerate elements? We told you up in the quantum number, the energy of the electron, student. Energy of the electron is decided by which quantum number? 1n, principal quantum number. And second, L quantum number. L is what? Azimuthal quantum number. If the orbitals have same value of n and L, if orbitals have same values of n and L, then what will happen? N plus L will be same. Tell me, yes or no? Same. If they are the same values of n plus m, then what will happen? Their energies will be same. Energies will be same, and then they are called degenerate orbitals. ठीक है? They will be called degenerate subshells, student, or orbitals. Are you with me, students?
Yes, sir.
Example you want. If I say, student, there are 3p orbitals. How many are there? If n is equal to 2, students, you are saying L can be 0 and 1. When n equal to 2, L equal to 0, this is a 2s orbital. There is only one, because the magnetic quantum number gives 2L plus 1 is equal to 0 plus 1, only one value. But when n is equal to 2 and L is equal to 1, then ML values are how much? 2L plus 1 is giving me how many? 3 possibilities. So we are saying when L is 1, students, there are 3 p orbitals. How many? 3 p orbitals. So this when L is 1 and n is 2, how do we represent it? There are, which are these p orbitals? You are saying one is 2px, other is 2py and 2pz. These are my 3p orbitals. The value of n for each one of them is how much? 2, and the value of L for each one of them is 1. So n is equal to 2, L is equal to 1. Here also n is equal to 2, L is equal to 1. Here also n equal to 2, L equal to 1, students. So what is the then n plus L value for 3, 3 and 3? So these 3 p orbitals are degenerate. Degenerate means they have the same energy. So when I say 2px, where they are coming, this is my K shell. You have only one S. And in the L you are saying you have 2s, and 2s will be n equal to 2, L equal to 0, 2. This will be lower in energy. Then you have 3, 1, 2, and students 3. They are same energy, student. What I'm saying, they have the same energy, 2px, 2py, 2pz. So there are 3 p orbital, students. They are degenerate. Means they have same energy. ठीक है? Further, students, another example. Supposing if I take students 5d orbitals. When I say n is equal to 3, L can be 0, 1 and 2. If n is 3 and L is 2, then ML values are how many? 2L plus 1 will mean 2 into 2 plus 1. There are 5 possible d orbitals. Of the different orientations, I told you they have different orientation, double. So these values, how do we represent, students? We said they are represented as plus L, 0 to minus L. So starting from plus 2, plus 1, 0, minus 1, minus 2, I am saying there are 5 d orbitals. How many? 5. So if I represent them by a box, one orbital I represent by a box, student. How many? 1, 2, 3, 4, 5. So these are the five, these are the, supposing this is my 3D orbital, student. How many are these? Five. They are degenerate because their n plus L values are same, students. They have the same energy. They have the same energy, but orientation is different. Orientation is
Different.
different. So one of this will be dxy, other is dxz, dyz, another is dx square minus y square, dz square. Okay? Got it? You want to see the shapes of them, you can see in the books. So this is the idea of the degenerate orbitals. Okay, so this is important. Now students, you have seen there are, you are saying that in what we are saying, there are shells which are given by principal quantum number 1, 2, 3, and so on. Then you are saying there are sub levels, student. Which sub levels you have seen? They are given by the values of L, values 0, 1, 2, 3, and so on, S, P, D, and F. Okay? And then you are saying there are orbitals, students. Orbitals, and you are saying that which orbitals you are talking about, 1s, 2s, 2p, dp. So students, the orientation of orbitals and the number of orbitals, how many orbitals are there, student? You are saying s is only one, p how many p orbitals? Fast 3,
Yes, sir.
and d how many?
4.
5. For where
5,
is the
sorry.
4?
Sorry,
F
5.
how many? 7. So this is the number of the orbitals which are possible as given by 4 set of quantum numbers. By given by 4 set of, so I may represent it by one box. P I may represent how many? 3 boxes. Each box is an orbital. Each box is an orbital. D I may represent by how many boxes? 1, 2, 3. 1, 2, 3, 4, 5. It is just our representation, students. And F how many I am drawing? 1, 2, 3, 4, 5, 6, and 7. Okay? So far F I have drawn 7. Okay? There are 7 F orbitals, there are 5 D orbitals, there are 3 P orbitals, there are S electron. And in each orbital, student, in each orbital, maximum of 2 electrons can live. How much? 2 electrons. Maximum of 2 electrons can live in each orbital. Maximum how many? 2 electrons. So in s orbital, what is the maximum number of electrons? Tell me. In s orbital, student, what is the maximum number? Only one? Two. In p orbital, what is the maximum number of electrons? There are 3. So 2 into 3, how much? 6. In d, what is the maximum electrons you can put? 2 into 5, 10. In f, how many maximum electrons you can put? Fast. How much? 40. Is it clear? This is the maximum number of electrons you can put in s orbital, p orbital, d, and f orbitals. Clear? Tell me. Clear?
Hmm.
Is it clear?
Yes, sir.
Okay. Keep your energy levels high. So this is the maximum number of electrons which are possible in each orbital, in s, in p, in d, and f, student. Now the question is, how will we fill the electrons in these atoms? The different, or interesting thing is that different orbital, students, different orbitals are in different shells, yes or no?
Yes, sir.
And they have different energies, yes or no?
Yes, sir. Yes, sir.
And the number of orbitals we have already told you. S how many? 2. P how many? 3. D how many? 5. F how many? 7. So they have different energies because they are in different shells. Okay? So how will we distribute the electrons in these shells, students, in these sub shells or in these orbitals? And you know maximum number of electron in each orbital is how much? 2. Maximum number of electrons in any orbital, maximum number of electrons, student,
Acha. Okay.
in any orbital is 2. You cannot put more than 2 electrons in any orbital. Just consider a bed, student, double bed only. Only two persons can sleep on a bed, not more than that. So only two electrons can live in one orbital. So on that basis, student, we have to build the electron distribution. Electron distribution. And important thing is, students, there are certain principles which we will be using for building up the electrons. So first part is our first most important is the Aufbau student, building up principle. So certain principles we are going to use, students, for writing the electron configuration of different elements. Okay? What we are going to do, write the electron configuration of elements. First one is the Aufbau building up student principle. What is the Aufbau principle? Aufbau is a German word, student. Aufbau is a German word. The process of working out electron. So what it says, electrons fill the sublevels from lowest energy. The electrons fill the sublevels. ठीक है? Sublevels in the energy levels, or subshell in the energy levels, students. ठीक है? ठीक है? Upwards, levels upwards. First, lower energy sublevels are filled. Okay? And then the next energy, first will be the lowest sublevel which will be filled, and then they will go to higher sublevels. So because the lower sublevel energy filled is because it has the lowest potential. You understood the meaning? Lowest potential energy. Therefore, we have to know what is the order of the energies of the different sublevels, subshells. So we should know what is the order of energy. What is the order of energy of different subshells, student? So what subshells you are having? In the K shell you have only one S. In the L you have 2S and 2P. In the third shell you have 3S, 3P. So what you are saying, you have 1S, 2S, 2P, 3S, 3P, 3D, 4S, 4P, 4D, 4D. Just a minute, pen. So how many you have, student? You have 4P. You have just you have 4S, 4P, 4S, 4P, 4D, 4F. All these orbitals are there, students. So
Yes, sir.
we should be able to know, students, the energy distribution. What we should know, student, their energy distribution. So how do we decide which is lower in energy and higher in energy? So if I know, student, the order of the energies, if I know the order of the energy, student, then I can fill the electrons, because I have already told you what is the maximum number of electrons that I can put, student, in any orbit. Okay, students? That we already told you, student. Okay. So the Aufbau has given a scheme, student. Aufbau has given a way to find the energies of this orbital. Student, in general, I can say that n plus L values represent the energy. Okay? Represent the energy of different orbitals. Okay?
Yes, sir.
The lower the value of n plus L, lowest value of n plus L means lowest energy. Lowest energy. For example, if I have 1s, n is 1, L is 0, n plus L is how much? 1. If I have 2s, n is 2, L is 0, then what is 2? 2 plus 0, 2. This means 1s is lower in energy than 2s. And if I write students 2p, for 2p, what is n is 2 and L is 1. So this will be 2 plus 1, n plus L value. This is my n plus L value. This is 3. So this will be higher in energy than 2p. Therefore, the energies can be calculated on this basis. And if n plus L value is the same for certain orbitals, then the lower n value, if n plus L values are same, then the lower n value is considered as lower energy. Subshell. ठीक है?
Yes, sir.
So by using this formula, students, we can try to fill the electrons in these sublevels or in these orbitals. Maximum in S2, in P how much? 6, in D 10, in F40. And students, either way we can work out this way, or another way is that you will see that a scheme has been given, student, a diagram has been given in the books. In your book also there is a diagram, student, to remember, to in order to remember the order of energies. Order of energies, student, in which the electrons will be fed, in which the electrons will be fed, students. What is important? The order is like this: 1s is less than 2s, 2s, then you have 2p, then student you have 3s, you have 3p, after 3p, student, you have 4s, then you have 3d, student, after 3d you have 4p, and after 4p you have 5s, student, then
So
after
wait, sir,
5.
there's I need to.
Huh?
Can I go to the washroom?
Yes, you can go ahead. I'm just writing for the timing. You can go. For 4p is less than, student, 5s, then 4d. After that you have 5p, then 4f, students, and then 5d, and then you have, student, after 5d, students, you have 6p. This is the order of the energy, student, which can be calculated on the basis of n plus L values. Or student, what has been done in order to remember this for the exam, students? We have to learn this, student. Then only we will be able to write the electronic configuration. We have to learn this. You can note down this, students. So there is another way of, student. What is another way to remember this? The order of energies can be remembered by a diagram, student. The
Okay, sir, let's continue.
okay
Can you
order
go up?
of
Can you go up? I need to check one hour.
okay, students. What I am saying, students, I am saying, if I know the order of the energies, then I can fill the electrons. Lower energy will be filled first, and then I will go to higher energy, students. Lower energy, then higher energy. This is given by the Aufbau principle. What is the Aufbau principle, student? Mean building up of the electron distribution in the atom. The lowest energy orbitals are filled first because they have the lowest potential energy. Lower energy means more stable, student. So one way is to find their n plus L values of the different subshells or orbitals, and on that order of energy comes the order I have shown. This order will be available in your books also.
Okay,
First
sir.
1s will be filled, then 2s, because these are lowest in energy. After it is completely filled, then I will go to 2s, then 2p, 3s, like this. Okay? So this
Yes,
is
sir.
the way the electron will be filled in the different subshells. Now the question is, students, how do I remember this? So in the book, student, you will find that they have given a diagram to remember the order of filling of orbitals. What we are filling orbitals with? Electrons, students. You are going to fill electrons in the orbitals. according to the Aufbau principle. Lower energy will be filled first, then you will go to higher energy. Because lower energy means the lower potential energy, and everything wants to have a lowest energy student, lowest potential energy to be more stable. And
Okay, sir.
the one of the way you will see is a diagram student which is given in the book. What they say, you can try to remember it. You are saying 1s, 2s, 2p student, then you are writing 3s in the, this is my k shell. In the k shell, how many orbitals are there? Only one. In the L shell, you have how many? If I say k shell 1, in the L shell, how many orbitals? Only 2. 3s, 3p, 3d. This is which one? And k shell, L shell, M shell. Okay? And in the next shell, you will have how many subshells student? How many orbital? 4s, 4p, 4d. You can make this students just to tell you how to learn it. You can have 5s, 5p, 5d. I don't need beyond 5f. 6s, 6p, 6d. ठीक है? I will not need 6f. Even if you write, it is not required. Only 7s and 7p. Total atomic number, how much you have in the periodic table? Maximum you have 118. So you put arrows like this, student. Arrows like this. Put the arrows like this. Can you put arrows like this? You can see.
Yes, sir.
All right, students. These are the arrows. So now I will fill in what order? First 1s. After that, student, you cross it like this. After 1s, what is coming? After 1s, which orbital is coming?
2s.
2s. And after that, student, let me take a different color so that it can help you. After that, student, this is, I'm taking black color. So after 2s, student, I am coming to this point. What is that? 2p.
2p.
And then what is that? 3s.
3s.
Then student, I am coming to this. After 3s, which is coming, student?
3p.
3p. 3p. After 3p, what is coming? 4s. After 4s, students, what is
3d.
coming? 3d. And then I
4p.
come 3. After 3d, what comes? 4p.
4p.
Then after 4p, 5s.
5s.
And then student, okay, join it here. What is coming then? 4d, 5p, 6s. Now let me join here, students. Then what is coming after this? You are getting 4f,
Yes, sir.
5d, 6p, 7s. And if I join like this, students, what you are getting? 5f, 6d, 7p. So students, this is a diagram which will be available in books also, which can be used in order to fill the electrons in the orbitals. Therefore, students, Aufbau diagram you can see in the book, no problem. It is just a way to represent it. Now, student, let me take some examples. Supposing, students, I have a carbon. I have to write the electron configuration. Which rule I am using? Aufbau principle.
Yes, sir.
Okay. How many electrons are there? Carbon is 6. Atomic number is 6. What is the number of electrons? How many electrons are there in carbon? 6 electrons.
Yes, sir.
So students, first the electrons will go into the lowest. Which one is the lowest, student? This is my K shell, supposing. Okay? You have in the K you have one s orbital. ठीक है? Tell me what is the maximum electron I can put in one s? In the s orbital, what is the maximum?
Uh,
2.
O2.
So you are saying 1s2. After that will come the next shell, which is my L shell. ठीक है?
Yes, sir.
In L shell, you have first you have 2s, and then you have how many? 2p,
2p.
2s and 2p. This is after this energy. So how many you can put in 2s, students?
2.
2. And what is left out? 2p2.
2.
Therefore, the electron configuration of carbon is 1s2, 2s2, 2p2. ठीक है, students?
Yes, sir.
But there is one problem coming, student, because if I show them by boxes, if I say this is my 1s, you are saying this is my 2s, one box, and you are saying this is my 2p. ठीक है?
Yes,
How many are
sir.
these? 3. You are saying one electron here. First it is filled completely, then it is filled completely, then 2 are left. Now how do I put 2 electrons? 3 boxes are there. Either I put it this or I put here. Now the question is where the electrons will go. In order to decide these, students, you should know that there is a Hund's rule of maximum multiplicity. Now I come to another rule, student. Another rule number 2, to write the electron configuration. What is that, students? These are degenerate orbitals. These are degenerate. Means they have the same energy. Which one?
Same
2p
energy.
x, 2p y, 2p z. There are 3 of them. 3 of them, students. They are degenerate orbitals, 1, 2, 3. Now how do I put the electrons in them? So we are coming to Hund's rule, student. What is the Hund's rule? What is the Hund's rule, student? Hund's rule of maximum multiplicity. So now I have given you the first one of Bohr principle. What it says that electrons are first filled singly. ठीक है? Electrons are first
Yes, sir.
filled. Electrons are first filled singly in the degenerate orbitals. First they will filled singly, students. ठीक है?
Yes,
And
sir.
after that pairing will start. After that pairing will start. In other words, students, what I did, what I am trying to say in this case, student, you have said कि in this the electrons are singly filled. I do not write 2p like this. No. And this is the correct order. Because they are degenerate, 2 electrons could be put like this, but this is a pairing is not allowed. First they have to be filled singly, then only pairing will be allowed. What is this called? Hund's rule of maximum multiplicity. When the orbitals are of equal energy, orbitals are degenerate, students. First you will fill singly. After they are filled singly, then pairing will start. Clear?
Yes, sir.
So pairing of electron in the same subshell does not take place until each orbital belonging to subshell has got 1 electron each or is singly occupied. Pairing will not start till each orbital has got 1 electron, which are degenerate. After each degenerate orbital has 1 electron. After that pairing will start. Clear? This is called Hund's rule of maximum multiplicity, students. Now, there is another important rule, students. The third one is coming. The third rule which I am talking is called Pauli's exclusion principle. Pauli's exclusion principle. what it says, students, that when you are saying in one orbital, what is the maximum number of electrons? Just tell me fast. Maximum number of electrons, how many can be the maximum number of electrons in one orbital? 2.
2.
But you cannot have all the 4 quantum numbers same for 2 electrons. Therefore, students, what will happen? Only 2 electrons, only 2 electrons can be filled in one orbital. ठीक है? But they must have opposite spin, students. Opposite spins. That is why I talked of the spin quantum number, students. But I talked spin quantum number. That they must have opposite spins. They cannot have the same spin, students. They must have opposite spins, students. These 2 electrons must have opposite spins. Only 2 electrons can live, but they must have opposite spins. So when a 1s orbital is there, if you put a 1 electron like this, I put another like this. Similarly, if I have p, students, if I have supposing 2p4, then what it means? 1, 2, 3 and 4th will be like this. So in each orbital, students, the 2 electrons will have opposite spins, means one is clockwise plus half, and other spin of the electron is minus half, means anti-clockwise. The same way I can say no 2 electrons in an atom can have all the 4 quantum numbers same, or I can say no 2 electrons in an atom can have all 4
No, not yet.
quantum numbers same. They must have at least 1 quantum number different. No 2 electrons in an atom can have all 4 quantum numbers same, students. This is the important rule, student, which is called Pauli's exclusion principle. You have noted this?
Yes, sir.
Okay. Very important, students. For example, student, now we have to write the electronic configuration of oxygen. O8. What is the atomic number of oxygen? 8. How many electrons? How many total electrons?
8.
8 electrons. So if I say, you are saying 1s2, 2s2, then what is 2p? How many are left? How many you can put in p orbital?
You can
Maximum
put 6.
2p, 4.
4.
Now if I have to represent it, student, this is my 1s, this is my 2s, and this is my 2p. 1s you put 1, then you cannot put of the same spin, opposite spin. This opposite spin. Then here what rule I have used? Pauli's exclusion principle. Which rule I used, student? When the 2 paired electrons must have 2 paired electrons must have opposite spins. Yes or no? Okay? After that, 4 electrons. Then what rule I will use here? Hund's rule.
Yes, sir.
You are using Hund's rule. What it says? When you have to fill 2p4, student, which rule you are using? Hund's rule of maximum multiplicity. What it says? First electrons will be singly occupied. No pairing will start till the degenerate orbitals are completely filled. After these 3 orbitals, 2px, 2py, 2pz are degenerate, students. So how you are putting 1, 1, 1. Got it? First you are putting 1, 1, 1. After they are half filled, completely filled, then what will happen? The pairing will start. Now pairing will start. ठीक है? After they are first completely singly occupied. Each electron singly occupied. Now the pairing will start. Next will go here. So then fourth electron will go, student, like this. ठीक है? So this is the correct way of writing the electron distribution, students. Any doubt?
No, sir.
You can put this electron anywhere, second, doesn't matter. Doesn't matter because they are equal degenerate. But by convention, students, we try to put in the first, which we show it here. So students, we can now start writing the electron configuration of different elements students, by using these set of rules. And I hope we have taken sufficient time to explain this, students. Therefore we will continue more about this and do a lot of questions on electron configuration and distribution in our next chapter. So we have already discussed the rules on the basis of which we are writing the electron configuration. So my best wishes and wishing you a bright and happy, prosperous new year, students. Work hard and then good night. I will meet you in my next class. Bye bye.
Bye bye, sir. Happy New Year
Okay.
again.
Happy New Year to you. Best wishes.
Thank you, sir.